the file in WhatsApp, but it's like sending. Yeah, sending. Not sure whether you get it. Huh? Hello? So it's still sending. But anyway, hopefully you can still follow. Let me share with you the slide. Okay. So this is chapter 2. Okay. So I'm going to record now. Okay, Bismillahirrahmanirrahim. We are going into the third topic. Yeah, the third topic in this chapter 2 on sampling distribution, which is going to be on single proportion. And you can look into your textbook for pages 46 to 50. All right. So this time you should be able to write down the sampling distribution of a single proportion. We are talking about proportion for sample. And for this particular variable, you have to apply continuity correction factor. Okay? At this point, some students may be confused a little bit. Okay, it could be mixed up with the first topic when we deal with X bar, especially when we sample from non-normal distribution. Okay, and once you are clear on the random variable, which is single proportion, and then you get the distribution, and before you can calculate the probability, you need to consider the continuity correction factor first, and only then you should be able to calculate the probabilities related to this particular variable. Are you okay, guys? Can you hear me? Okay,
Yeah.
Can hear me
my
very good.
Okay, this is the sample proportion. Okay, sample proportion is defined by x over n. X over n. Remember when we learned about binomial distribution, you do have the number of successes in n trials. Okay, for this particular topic, the number of trial there is the same as the sample size. We have n. So don't be confused with the sample mean. Okay, in the sample mean, when you learn about sample mean, you sample from binomial distribution where the number of trials and the sample size can be different. Okay, but for this one, we talk about P directly from pi, which is realized from binomial distribution. So if you can recall your binomial distribution, the x here is actually binomial. X here, okay, this x is binomial random variable where the number of trial is n. That's why I said for this particular topic, we assume the trial here n is the sample size. Okay, and we do have population proportion, which is denoted by pi. So this is the population proportion, whereas P is the sample proportion. Okay, so from sample to sample, you could have different P values. So different P values can be represented by a variable which is denoted by capital P. Okay, So what happened when the number of trial or the sample size is large? Then, okay, so from discrete random variable x here, P can be approximately normal by central limit theorem. Okay, so P will be approximately normal. When it is normal, then what is the mean? The mean for P is actually the mean for x over n. So you just imagine you have mean for x is n pi divided by n. So n gone, you are left with pi. So you have the mean for P is pi. Similarly, for the variance is the variance for x over n. So variance for x is pi times 1 over pi. Okay, pi times 1 minus pi, isn't it? Divided by n. And then you can see that this is the variance for P. The variance for x binomial is pi times 1 minus pi. Okay, but the variance for P is the variance of x over n. So you have pi times 1 minus pi over n. That's why you get this variance. But you don't have to prove anything anyway. So this distribution is available in the statistical booklet. And for this particular topic, we only focus on large sample size. Okay, in the previous topics, if you sample from normal distribution, you can have small sample size or large sample size because you know eventually x bar or x bar 1 minus bar 2 will be normal. But if you sample from non-normal distribution, then you have a condition that sample size or sample sizes have to be large. So in this topic, we only focus on large sample size. Okay, we don't look into small sample size. Okay, Marzuki? Yeah? Alright. So we can use this normality assumption again, right? And we know this is continuous. Okay? So if you look at this situation from discrete x here to continuous, where p here is x over n. N is just a constant value, okay, super size. But the variable here from discrete to continuous, okay, different from the case where you learn about x bar. Although the x is discrete, but x bar actually contains x1 plus x2 plus x3 plus x4 and so on until xn. So you have many x's. So you don't have to worry about continuity correction. But here, p is actually a single x, which is really a discrete random variable. And then you approximate the x over n, which is simply p, to normal, continuous. So in that case, you have to be careful when you want to find the probability for P. Okay, so in this particular topic only, you need to do the continuity correction factor before you standardize. Okay, continuity correction factor only in this topic. So before we go into the continuity correction factor, let's look at how you standardize. Since you know the distribution for P, then the standardization is just the variable of interest P this time minus its mean, which is pi, divided by its standard deviation, which is pi times 1 minus pi over n. Okay. Before this, you had x bar minus its mean mu divided by its standard deviation sigma squared, square root of sigma squared over n. When you had x bar 1 minus bar 2, then z will be x bar 1 minus bar 2 minus its mean mu1 minus mu2 divided by its standard deviation, which is the square root of sigma 1 square over n1 plus sigma 2 square over n2. Now you have p. So the standardized random variable will be the random variable of interest, which is p, minus its mean, which is pi, divided by its standard deviation, which is square root of pi times 1 minus pi over n. And again, this standardization is available in your statistical table, booklet page 2. Okay, so you can refer to your stat table. Always have your stat table when you do any exercise. Okay? Yeah, on page 2, you do have that. Okay. In fact, page 3, yeah, the distribution for P is on page 2, but the Z expression is on page 3. So you can look at the booklet and check it out. Okay. So Z is standard normal with mean 0 and 1, and then you can use your calculator when you get to Z. But then before you standardize, this is what you have to do. You have to take into account the continuity correction factor. This is a must. So for P, it has to be plus minus 1 over 2n. Okay. At X level, you have plus minus 1 over 2. So X is binomial. When you talk about approximation to normal, you will have plus minus a half. Okay. But if you divide X by n, then you will have plus minus 1 over 2 over n. So basically, that is 1 over 2n. Okay. So you need to think about when are you going to plus, when are you going to minus 1 over 2n. Okay. You have to do this before standardization. Okay. So let's look at how you standardize. You need to think logically, don't memorize. Okay. So continuity correction factor, the question is, are you going to plus 1 over 2n or are you going to minus 1 over 2n? Okay. Please be cautioned with the inequality sign. Again, for x bar 1 minus bar 2, you don't have to worry about less than or equals to, greater than or equals to. You're not sensitive to the inequality. But for proportion, yes, you have to be very careful. It's like dealing with discrete case. Okay, when you talk about less than or equals to, what do you mean by not more than? What do you mean by at least, at most, between, and, from, to? So you have to be very careful. What do you mean by that expression? Okay, because it will influence you whether you have to plus or you have to minus 1 over 2n. So example 1. Suppose you are trying to find the probability of P. The outer P is the probability, the inner P is the proportion. Our random variable in this topic 3. So you want to find the probability that P is equal to, okay, equal to. So here you have to, how do you deal with this? So you can demonstrate P equal to 0.3 at this point. The solid, okay, the solid point here, okay, the solid dot here, the red one. So suppose that is 0.3. At a continuous level, you are talking about a value below 0.3 up to a value above 0.3. So for this particular example, when you CC, it means you have to start from a value below and up to a value above. Meaning you have to minus 1 over 2n up to 0.3 plus 1 over 2n. In terms of the probability, okay, when you CC, okay, when you CC here, you have to consider the area. Okay, remember the probability is actually the area from 0.3 minus 1 over 2n up to 0.3 plus 1 over 2n. This is when you have equal. Find the probability that the proportion is equal to 0.3, for example. Find the probability that the proportion is 0.2. So you have to have minus and plus. Eh? That is the first example. The second example, how do you find probability of proportion less than 0.3? So you cannot standardize it away. Many students in the past couldn't care about standardizing, continuity correction factor. They don't care. They should always standardize, so they lose mark. Okay? They cannot get full mark. So you have to show the continuity correction factor. So if you want to get some idea, then okay, less than means you have a blank circle. Blank circle means 0.3 is not included. Okay, so that is 0.3. So you demonstrate that using a dash line, meaning you don't want to include 0.3. Okay, because it is less than, isn't it? It does not touch 0.3. So when you say less, so it has to be up to a value just before 0.3. Okay, so you have to minus in that case. Okay, so the area that you want to find is the probability P be less than or equal to 0.3 minus 1 over 2n. Okay, so you don't want to include 0.3, so you have to stop just before 0.3, so that's why you have to minus. And notice the change in the inequality here. Less than, you use dash line. When after the CC, you change to less than or equals to. So the area is up to 0.3 minus 1 over 2n. Okay, let's look at another example. P greater. Again, you can use the line here. Greater means you don't include 0.3. So you use the blank circle and a dash line. So the area has to start from a value slightly above. In that case, from 0.3 to this value, it has to be a plus, isn't it? So you have to plus 1 over 2n. Okay? And after that, then you can standardize. Are you okay so far, guys? Are you okay so far? Can you follow me?
That's it.
Okay. Very good. Let's look at another example. What about greater than or equal to? Okay. So we have a solid circle here. Because we want 0.3 to be included. Okay, so we use a solid line. So the area has to include 0.3. So we start off from a value slightly lower than 0.3. Okay, so we want the area above a value slightly lower than 0.3. So in that case, we minus. Okay, when we CC, we have to minus. Okay, you can see here, greater than or equals to becomes greater than, 0.3 becomes 0.3 minus 1 over 2n. You start off earlier, so that 0.3 will be included in the interval. What about this one? Any suggestion? The first one, do you need to minus or plus? What about this? Can anyone answer this? What do you mean by P probability that P is greater than 0.2 but less than or equals to 0.3? You need to minus plus or plus minus or minus minus or what?
Minus.
The first one,
Minus.
minus.
Minus plus.
Minus plus.
Minus.
Minus minus. Any more? Okay, what do you have here? Any other answer?
Plus minus.
Plus minus. Sham. Is that Sham? Okay. Let's who
Yes,
who
doctor.
got okay, who got it correct? Okay. So we have the line 0.2 not included. Okay. So you have a blank circle. Farabi minus plus. We will see. Okay, whether Sham is correct or you are correct. Okay, Megat minus plus. Okay, so we have 0.2 not included, okay? And 0.3 is included. Afiq Najmi. So you have the same idea with Sham just now. Plus and minus, isn't it? You don't want to include 0.2. So you have to exclude 0.2. So you have to start off from a value slightly higher. So in that case, you have a plus. Okay, you have a plus here. So you want to have from this area above 0.2 up to slightly greater than 0.3 because you want to include 0.3. So in that case, the first one you have to plus. You start a value slightly higher. You don't want to include 0.2, so you have to plus here. Plus, so that you start with a value slightly higher than 0.2. But for this one, cannot lah, cannot minus kan? Because you have to include 0.3. So even Syam pun salah. Syam pun incorrect. Najmi pun incorrect. So 0.3 has to be included. So you have to plus also. So it's plus plus. Okay? So when you CC, it has to be a plus plus. Okay? 0.2 plus 1 over 2n. 0.3 plus 1 over 2n. Okay? So let's look at another one. Other examples, again, you can try this out. If you have from 2, yeah? So here, you want to include 0.2, so you have to minus the first one. Okay, you have to minus because you want to include 0.2, and then up to 0.3, you have to include 0.3 as well, so you plus. Okay, that's how you do it. Next, here you don't want to include, not including 0.2 and 0.3, so you have to plus the first one, but minus the second one. Okay. And also the last one, here you want to include 0.2, so you have to minus, you start from a value below 0.2 so that 0.2 is included, but you have to stop just before 0.3, so you stop at a value lower than 0.3, so you have minus. Okay? So you can have many other combinations. What I can suggest, okay, please do not memorize, but think logically. Okay, you need to think logically. Okay, on this CC. Are you okay, guys? So practical examples, you can have a look at 2.5. Okay, what you need to do is to observe the following steps. The sampling variable of interest. Of course, when you talk about the proportion, there's no mention about sample mean, sample average. Usually, you will have in terms of percentage, probability of a percentage, probability of a fraction, probability of a ratio. Okay, so this refer to the proportion. Very clear question will be probability of a proportion. Okay, so no average, no sample mean, no difference between two means are mentioned. You only talk about probability related to fraction, proportion, percentage, ratio. These are under proportion. Okay. Once you know the variable of interest, look at the distribution, how the questions are formulated, and how the CC is included, okay, in the step. And then, of course, you need to know how the questions are finally solved. So you look at that example, inshallah. I want to show you this one example very quickly. We are talking about what is the probability. Okay, here in task 2.6, you are talking about percentage here, which is proportion actually when you turn that percentage into a value from 0 to 1. So here you have 0.9 automobiles that will not be rejected because machine failure. So you look at the probability that you want to find is related to the percentage. Percentage. Here, percentage again. And I just add another question which is not in your book. And this is very common, where in one question we can ask you differently. Yeah, whereas while the first two questions were asking about proportion that will not be rejected, suddenly you have the last question here, at least 6% automobiles will be rejected. Okay, so you have to be very careful. Are you going to use the same distribution or you need to update your distribution? Okay, so this is very common question in assessment. Okay, so since you can see it all on proportions, then you need to define your distribution for the proportion. The first two questions were asking about proportion that will not be rejected. Okay, so you have these proportions in blue relate to not rejected, not will not be rejected, but the red one here, the last one, is related to those that will be rejected. So you have to use the distribution, okay, accordingly. For the first one and the second one, you will use this distribution, okay. If you define pi to be the population proportion related to this which will not be rejected, okay, then you can use that pi value in the distribution for p, where p here is the sample proportion of automobiles that will not be rejected. So you can use pi in p. So pi and p has to be consistent. Okay. So p here is the sample proportion of those which are not rejected. So you use the pi value here and get the variance pi times 1 minus pi over n. So use this distribution to solve number 1. Okay, number 1, you want probability of not less than. So again, be careful with the wording. Not less than means at least. Okay, and you can use P. But remember, when you use P, you have to standardize first. So how do you standardize? Remember, when you include like this, greater than or equals to, then you have to start with a value slightly lower. So you have to minus. So simplify and then only you standardize. Okay, after standardization only, you get from your calculator. Are you clear, guys? We will stop for a while. Okay, we will stop uh in 5 minutes time, inshallah. Okay, so just bear with me for a while. The second one also, we're talking about the proportion of these automobiles that will not be rejected. So you can still use the probability distribution for P. Okay, so when we say between n, means that you have from you have 0.88 less than P less than 0.92. Be careful with the inequality. Between means you don't include. If it's from 2, you include both values. So for this question, you see C means what? The first one you plus, the second one you minus. Okay? So, and then you simplify first. After that, you standardize. Okay, only after CC, you standardize to Z and use your calculator, check your answer. That should give you this value. Okay, of course, you can see that this value is slightly different from what the book give you, because using calculator, the value can be more accurate. Okay, the textbook make use of the table. The table allow you the Z values up to 2 decimal places only. Okay, but if you use your calculator for Z value up to 2 decimal places, you will get exactly the same answer. What about number 3, which is not in the book? Okay, now you want to use to find at least 6% of automobiles will be rejected because of machine failure. What is the probability for that? Okay, so you cannot use P anymore. You cannot use the distribution for P because P is for those which will not be rejected. So you have to use Q. Q is the complementary for P. Okay, so the way you define Q will be 0.1 here. The mean has to be complementary of the mean for P. So if you add these two, it has to sum up to 1. However, the variance must be the same. And the variance must be the same because you're talking about pi minus 1 minus pi times pi. So it's the same thing over n. So use Q to solve number 3, not P. Okay. So you want to find the probability of Q, the proportion of automobiles that will be rejected is at least. Okay, at least. So again, CC please. Oh, I shoot that one first. Okay, so CC please. So when you CC, you have to start from a value slightly lower, and this is the case. You standardize, okay, and then use your calculator straight away. Are you okay, guys? So far, okay. So it's very hopefully it's clear because the only new thing here is the CC. Okay, the rest, the distribution, the standardization, how you solve or how you get the value from the calculator is all the same for all 3 topics so far. But the only new thing that you have to be careful is the CC. So you should be able to write down the sample distribution of this single proportion correctly. Do you think you can do that, guys? InsyaAllah, can The second learning objective. Any idea to apply continuity correction factor? Yes or no? At least you get some idea, right? How to deal with that. Okay, very good. And finally, hopefully you should be able to calculate the probabilities correctly for the single sample proportion. So I think that's it for this topic 3. Okay, so uh, we uh, we can dismiss now unless you have a question before I close the session. Okay, so if there is no question, I believe
Doctor, if we have question, can we discuss it on the next meeting on Monday for the test?
yeah, you want to discuss it now or next?
No, I will combine all the question when we're doing the revision, and we can discuss it on Monday before the test.
Yeah, sure. You can collect all your questions and we will
Okay.
discuss on Monday for section 41. Okay, what I am going to do on Monday for section 41, we are going to have the last topic for first hour, and the second hour we will just do revision, meaning you can just ask any questions. So get your questions collected, and then you can just shoot your questions during the second hour. Okay.
Yeah, Doctor.
Okay, so that's it for now, guys. I will see you next week, inshallah. And of course, I will share with you the link for uh, last semester test 1 and also the supplementary exercise questions chapter 2. Okay. Thank you very much. Assalamualaikum warahmatullah, and I'll see you again very soon next week, inshallah.